Okay. So we're going to continue on with word problems, using equations to solve word problems. These ones are going to be a little bit more challenging, but the method is still the same, never changes. Set up your unknowns, create your equation and solve it, use that to find the answers. First problem. The length of a rectangle is 3 times its width. If the perimeter is 56 centimeters, what's the length of the rectangle? How many unknowns are there here? 2. What are they? Length and width. We know that this length is 3 times this. What do you want to call each? Let's call the width x, and the length is 3 times that, so it's 3x. So we finished step 1. Step 2, we got to make our equation. How do you find the perimeter of a rectangle? Adding all the sides. So how many of these do you have to add? 2 of them, right? Because there are 2 lengths in a rectangle. So remember, this is going to be 3x, 3x, x, and x. So to make the equation, you've got to add 2 lengths plus 2 widths. And that will equal the perimeter, which we are told is 56. Okay? Most common mistakes students make here is they just do 3x plus x. They forget to add the 3x twice and the x twice. So watch out for that with perimeter. What would you like to do next? And I get 8x equals 56. Well, get x by itself by dividing both sides by 8, and x equals 7. What does that 7 represent? The width. We are asked the length. So how would you calculate the length? The length is the width 7 times 3, which is 21. I've made a communication error. Thank you. Yeah. 3 plus 3 plus 1 plus 1. Yeah. Okay. So that's a new type of word problem, perimeter. Next, consecutive numbers. Well, before we do this, you have to know what consecutive numbers mean. Somebody give me 3 consecutive numbers. Sorry? Right. Somebody give me another 3.
1, 2, 3.
Somebody give me another 3. Come on.
7, 8,
Somebody give me another 3.
14, 15.
No, you already said something. Ah,
14, 17,
thank you. Somebody give me another one. One more. Come on, one of there. Somebody in there. Thank you. Okay. So what are consecutive numbers? They follow each other by 1. Okay. So we need to find 3 consecutive numbers whose sum, or they add up to 174. So there's 3 unknowns here. Number 1, number 2, and number 3. Let's call the smallest of them X. How do I get to the next consecutive number? Add 1, right? How do I get to the one after that? Adding 1 to this, which is adding 2. So those are expressions for 3 consecutive numbers that we don't know. What is my equation going to look like? Well, I'm going to add these numbers that I don't know. And it's going to equal 174 because it says the sum, so I have to add. And now we're solving equations again, which you guys should be quite comfortable with by now. So this simplifies all the way to 3x plus 3. Subtract 3 from both sides because we want to get x by itself. So we get 3x is equal to 171. Divide both sides by 3. And x is equal to 67?
57.
Oh, sorry, 57. 57. So therefore, the numbers are, wow, 57, 58, 59. And that's how you do consecutive numbers once. Okay. All right. This third one is a little bit different. Because when you set this one up, you're actually going to get variables on both sides. If Herman rents a car from Rent With Us, he pays a flat rate of $45 plus 5 cents for every kilometer he drives. So he's got to pay $45 before he even drives anywhere. And then every kilometer he drives before he returns the car, he pays 5 cents. If he goes down the street and rents a car from Please Rent With Us, he pays a flat rate of $65 a day, but not as much per kilometer, only 3 cents per kilometer. We have to find how many kilometers he drives so that the cost for each company is the same. What don't I know here? What am I trying? The kilometers, right? So that's the unknown. And we can call it X, but I might as well call it K. If you called it X, you're fine. Now we have to come up with expressions for the cost from Rent With Us and Please Rent With Us. So for Rent With Us, how much does he pay before he drives? 45. Plus 5 cents for every kilometer. 5 cents for every K, which would be 0.05 times K. That's how you calculate the cost for the kilometers he drives. We have to add 45 bucks because he has to pay that regardless. And that's an expression for the total cost from that company. Knowing that, can somebody give me an expression for the other one?
65 plus 0.0.
Exactly. He's got to pay $65 right up front, and he's got to pay 3 cents for every K. And notice, because we're in dollar form, we have to write these as decimals. We can't write 5K, because that's pennies. Now, how do we make our equation? We are trying to find K where these two equal each other. How How do I make these two equal to each other? Write one of them. And it has to equal the other. Notice this one's a little different, like I said, because it's got variables on both sides. Okay. All right. What do we do?
But you have to subtract 0.03.
Yeah, we've got variables on both sides, so I want to bring these over here. So how do I get rid of plus 0.03k? I'm minus 0.03k. And when I do that, I'm going to get 45 plus, what is 0.05k minus 0.03k? 0.02k equals 65. Next. Subtract 45 from both sides because we want to get k by itself. And I get 0.02k equals 20. And then divide both sides by 0.02. And I'm going to get the kilometers that I'm looking for. What do we get? 1,000? So that means that if he drives 1,000 kilometers, it doesn't matter which company he goes to. The cost is going to be the same. If he drives less than 1,000, then the cost for one's going to be better. If he drives more than 1,000, then the cost for the other one's going to be better. We'll talk about that later. So driving, you always want to finish with the sentence. 1,000 kilometers will result in the same cost. You want to make sure you have something like that. Okay. What is that? I have no clue what you just said to me. What is it? Sap? Can you not just tell me what it is? Spice. For what? Like to eat? Why is this so hard? I don't understand why this is so hard. You know why it's so hard? Because you're wearing your hair in a bun. I can't stand buns. Okay? Oh, ask former students. Because it looks like you got a growth on your head.
Yeah.
No offense, but I don't know why. It's just when I see them, I kind of, I don't know why I get bothered. It's just one of those things. I mean, we all have little things that bother us. Buns bother me. Could be, and man buns? Oh. Don't even. Like, don't even. Well, I'm recording this. Okay. All right. So you know how I feel on that issue. We're not going to worry about this one. We're not going to do this one. Okay. I'm not worried about that. Okay.